Hi everyone, we will be continuing with our topic analytical geometry. This is part 3 and I am your AKD sir in your very own channel Classes with Ivan. Now today we will be discussing the centroid of a triangle. Now you know centroid of a triangle means which is the point where the medians are concurrent, or which is the point where the one of the median or any of the median is bisected in the ratio 2:1. Now let us take one triangle ABC in the Cartesian coordinate axis, having its coordinates as x1, y1, as A, B is x2, y2, and C is x3, y3. So from the midpoint coordinate already we have done in your part 2, that D is the midpoint of BC will be having its coordinates x2 plus x3 by 2 and y2 plus y3 by 2, and this way the other two coordinates C and F will be as accordingly x plus x3 by 2, y1 plus y3 by 2, and here it is x1 plus x2 by 2 and y1 plus y2 by 2. So I have written this on the board, Now G is the centroid which divides the medians or any of the median in the ratio 2:1. Now let's take the median AD for our reference, and G divides that AD internally in the ratio of 2:1. Therefore G will be, according to our section formula, you can recall, okay, this is 2 into this plus 1 into x1 by m plus n means 2 plus 1, and here it is 2 whole into y2 plus y3 upon 2 into plus 1 into 1 divided by 2 plus 1, and that comes down to x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. It is very easy to remember, it is easy to remember. Okay, just 3 additions, x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 upon 3. G can be found to be the same point by taking the other two medians also, that is namely BE and CF. So in the classical geometry in your class 10, you have read already that the medians of a triangle are concurrent and their point of concurrence is called the centroid of the triangle. Here we have proved with the help of the analytical geometry also that shows that the medians are concurrent, they intersect each other at the point of G. Now let us work out two problems. Okay, the first question is, if the two vertices of a triangle are minus 4, 3 and 2, 6 and the centroid is the origin, then find the third vertex. This is the question. Okay, so what is the third vertex? Let you consider third vertex be HK. We do not know it. Therefore the formula that we worked out a bit earlier ago, it is minus 4 plus 2 plus h by 3 is equal to 0, because origin is 0, 0. Therefore here from you get h equals to 2, and from 3 plus 6 plus k whole upon 3 is equal to 0. This is a y coordinate, that is also 0, and you get k is equal to minus 9. So when you get the third vertex is 2 minus 9. So easy. Now next question. If the centroid of the triangle whose vertices are 2, 4, 3k and 4, 2 is k3, it is the centroid of the triangle whose vertices are given this. So find the value of k. Once again, very easy problem. Any of the two you can take, I have taken x1 plus x2 plus x3 upon 3 is equal to k. Here it is that. It is k, the unknown quantity. So 2 plus 3 plus 4 whole upon 3 is equal to k, and k becomes 3. Now let us solve one important theorem that you may have done in your class 10 days in the classical geometry, and now you will be proving it by the analytical geometry. Now what is that? Centroid of the triangle obtained by joining the middle points of the sides of a triangle is the same as the centroid of the original triangle. Here is original triangle ABC, and the midpoints PQ are respectively of the respective sides. We have joined that, forming the triangle PQR, and let us consider the centroid BG. When P is the middle point of BC x1, y1, Q is x2, y2, and R is x3, y3, respectively the midpoints of AC and AB. Okay. Therefore, G of PQR, what it will be very easy, you have done it already, that x1 plus x2 plus x3 over 3 and y1 plus y2 plus y3 over 3. Now B, naturally taking this into consideration, the B coordinates will be 2x3 minus h and 2y3 minus k, and C will be 2x2 minus h and 2y2 minus k. Now P is the midpoint of BC, and that is x1, y1 we have taken. Therefore, 2x1 is equal to 2x3 minus h plus 2x2 minus h, and similarly if you solve it, you get h is equal to x2 plus x3 minus x1, and similarly you can get that that k is equal to y2 plus y3 minus y1. Now the coordinates of B, that you have already taken it, that comes down to x3 plus x1 minus x2 and y3 plus y1 minus y2, and likewise the coordinates of C will be x2 plus x3 minus x1 plus x2 plus x1 minus x3 and y2 plus y1 minus y3. Now, hence you have got all the points A, B and C, and it is not difficult just to find out the centroid just by adding the x coordinates and dividing with the 3 and this with that thing, And once again you are getting the point, the centroid of the ordinate triangle ABC to be x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 upon 3, which is the same point G again, and that was our theorem that you have already done in your classical geometry in the class 10 chapter. Now, one case analysis, an important point we can get from here. What is that, if two vertices of a triangle are respectively x1, y1 and x2, y2, and you want to find out the centroid is given hk, and you want to find out the vertex. All these 3 points are given, two vertices x1, y1, x2, y2, and the centroid is given as hk. Then the third vertex is going to be 3h minus x1 minus x2 and 3k minus y1 minus y2. Very important one, you can use it, you can utilize it in your future problems. Now, let us take one question. Given the vertices of a triangle 1a, 2b and c square minus 3. Now there are two parts in the question, First is prove that its centroid conchuli on the y-axis. And the second is show that the centroid lies on the x-axis if a plus b equals to 3. Okay? So let us solve the first part. Centroid will lie on the y-axis. When the x-coordinate of the centroid is 0, because a point on the y-axis will have its abscissa 0. That I have done. So 1 plus 2 plus c square whole upon 3 is equal to 0. And this way you get that c square is equal to minus 3. Oh God! But if C belongs to a real number set, c square cannot be negative, because the square of a real quantity cannot be negative. Therefore, C will be imaginary. That is, G does not lie on the y-axis. The first part is proved. For the second part, so that the centroid lies on the x-axis if a plus b is equal to 3. Once again, the centroid to lie on the x-axis is y coordinate should be equals to 0. That is a plus b and plus minus 3 whole upon 3 is equal to 0. And thereby solving you get a plus b is equal to 3. And that was the condition you had to prove. Now let us solve another problem. You can recall this was set in your rider in your class 10 days, okay, in the classical geometry. Now let us solve it through the analytical geometry. What is the problem? If G be the centroid of the triangle ABC, so that AB square plus BC square plus CA square is equal to 3 times GA square plus GB square plus DC square, where obviously G is the centroid of the triangle ABC. Now, for the simplicity of our discussion, let you take the B vertex coincided with the origin, that is 0, 0. Let A be HK and C be C naught. Okay. And the BC, the length, that is C. Therefore, the coordinate of C is on the x-axis, it will be C naught. And A is HK. Therefore, the centroid G, it happens to be H plus 0 plus A by 3, K plus 0 plus 0 by 3, and it goes to H plus C by 3 and K upon 3. Now let us consider that the triangle ABC be in the first quadrant for the simplicity of our calculation. It is true for any other one, but for the simplicity of our discussion, our calculation, let us take this to be the first quadrant. Now let us take the LHS, left hand side of the given proof, that is ab square plus bc square plus c square. It is simply the distance formula. I have done it, and thereupon you get 2h square plus 2k square minus 2ch plus 2c square. This is the left hand side. Let you mark it as your equation number 1. Now come on to the right hand side. It is 3 times the distances, the sum of the distances j square plus dv square plus gc square. Once again the distance formula, 3 whole into this plus this plus this. Okay, and if you go on solving it, simplifying it, you finally reach that it is also the same 2h square plus 2k square minus 2ch plus 2c square. So from the equation 1 and 2, you get that the left hand side equals to the right hand side, that is ab square plus bc square plus c square, that equals to 3 whole times the sum of g square plus dv square plus gc square, and that is proved. And finally, I am closing this session of our discussion in the analytical geometry part 3. And before I end, I request you to subscribe, to share, to like my channel, and that will be giving me the boost. Thank you all.